But let's forget about primes for a little bit and talk about partitions, which is another one that was made a big deal out of in the movie. So the next number that we're going to talk about is P of n. Again, n can be some positive whole number. And P of n is going to represent the number of partitions of n. And there's a little scene in the movie where Hardy explains what this is, but I'll go over it again more slowly. Partitions are just the number of ways you can break up the number n. And so for n is 1, that's pretty much just one piece. You can't break up the number 1. But when n is 2, you have a couple of options. You can say that 2 is 1 plus 1, or that it's just 2. When n is 3, you can break that up into 1 plus 1 plus 1. You can break that into 2 plus 1. And you could call that just 3. I believe the example that Hardy does in the film is n equals 5. So how can we break up 5? Well, we can do 1 plus 1 plus 1 plus 1 plus 1. We can do 2 plus 1 plus 1 plus 1. We could do 2 plus 2 plus 1. We could do 2 plus 3. We can do 4 plus 1. We can do 5. Is there any other way to break up 5? I think we've got them all. The order doesn't matter. If I did 1 plus 1 plus 2 plus 1, that's the same as the second sum we have here. So if I wanted to think about P of n for each of these values of n, P of 1, well, how many ways could I break up 1? Just the 1. P of 2, how many ways did I break up 2? 2. P of 3, how many ways did I break up 3? 3. So far, it looks like the pattern might be that P of n is equal to n. That would be really easy. But here at 5, we see that's just not true. There's actually 6 ways. So P of n, or P of 5, is 6. So that breaks the pattern. It's not that P of n is always equal to n. And there's a couple that they cite in the movie where P of 100 is some ginormous number, and then they compute P of 200 in that contest with the major. So this number actually grows very fast. At the beginning, it doesn't seem too difficult, but this number gets really big really fast. And so the question would be, what can I use to estimate it? I wanted to use P of n is equal to n. But we found some ways where that's not, or some places where that's not true. So what would be a good formula to estimate it? Well, there's a lot of mathematics behind this estimate, so I'm not going to go into the details, but I will at least show you the formula that Ramanujan came up with. He said that P of n is about, it's not exactly, this complicated number. 1 divided by 4 times n times the square root of 3 times the exponential of pi times the square root of 2n over 3. And if you go back and look at the film and you pay very close attention when Hardy is talking to the group the second time around and trying to convince them to give Ramanujan the fellowship, you'll see this formula on the board somewhere. This is the formula that Ramanujan in real life did come up with for an estimate for the number of partitions of n. And it's close to the correct number by something like 1 or 2%, I believe. It's going to be close, but usually not exact. I mean, it has all these weird square roots and pies in it. But those are two contributions, two examples of contributions that Ramanujan made to mathematics in real life. And there are so many more. I mean, he had notebooks and notebooks full of formulas that he'd come up with when he lived in India, and then he did even more mathematics after he had moved to Europe. And so he made many contributions that mathematicians still use today in the field of number theory primarily is where he worked. But he made some contributions to analysis in some other areas of mathematics as well. Very accomplished for his young age.